One of the fun things you get to do is verify trig identities. So some of the tips I have for helping you learn how to verify trig identities, and to make sure it's clear, verify means prove it's true. So if they ask you to verify it, they're not saying, is it true or is it not true? They're saying, show that it is true. We know it is, but show it. So first tip I have, change everything in the problem to be in terms of sine and cosine. So I've shown here the other four trig functions and how they relate to sine and cosine. And these are things you just need to have memorized. Tangent is equal to sine over cosine. Cotangent is equal to cosine over sine. Cosecant is equal to 1 over sine. And secant is equal to 1 over cosine. So that can be a good first step in showing that a trig identity is true, changing everything to be in terms of sine and cosine. So I would always begin with that as my first step. Now the second tip is to know this trig identity. This is a Pythagorean trig identity. There's two others, but I think if you know this one, that's usually sufficient. Sine squared plus cosine squared is equal to 1, which if you've learned about the unit circle, you might actually be able to figure out why that's a Pythagorean identity. But if you don't know, that's okay. Doesn't matter for this lesson. But remember and memorize sine squared plus cosine squared is equal to 1. Now, like I said, there are a couple other trig identities that I think are also called Pythagorean, where two Pythagorean theorem or Pythagorean not Pythagorean trig equations are squared, but I wouldn't worry about them. But it is good to know, as I just showed you, sine squared plus cosine squared equals 1 can also be rewritten as sine squared equals 1 minus cosine squared, and cosine squared equals 1 minus sine squared. But those two I just highlighted are really just a rewriting of that original equation. So if you know the top line and understand it can be rewritten so it's equal to sine squared or equal to cosine squared, sorry about that, I moved the wrong thing. If you can see that that is the same, that's helpful, because sometimes you won't be seeing sine squared plus cosine squared. You'll just see sine squared or cosine squared or 1 minus one of those things and want to transition those. So for our first example, we have cotangent x equals cosecant x over secant x. So I'm going to go with tip number 1. I'm going to rewrite things in terms of sine and cosine. None of these three are in terms of sine and cosine, so I'm going to just use that very first tip and rewrite them in terms of sine and cosine. So just a second, sorry, I gotta adjust something so I can write on this. Here we go. Okay, so on the left side we have cotangent x, and if you remember, cotangent x is equal to cosine x over sine x. Sorry, I gotta adjust one more thing on my projector so this will work correctly. There we go, cosine x over sine x. And then cosecant x is equal to 1 over sine x. And secant x is equal to 1 over cosine x. So on the right-hand side, we have a fraction over a fraction. You got to remember that to divide by a fraction, you need to multiply by the reciprocal. So you can rewrite it. The top is 1 over sine x, or not rewrite, but just leave it. But then the bottom, you multiply it by cosine x over 1. So we've reciprocated the bottom. We flipped it over. We're dividing by, or multiplying by the reciprocal. So the left side doesn't change. I just rewrote cosine x over sine x. But the right side, if I combine those two fractions into 1, it gives me cosine x over sine x. And then you can clearly see the two sides are equal. So we have verified that it is an identity. Our second one, we have sine theta equals cosine theta times tangent theta. Theta works just like x. It's a Greek letter. Don't let it throw you off. It works the same way x does. For some reason they like it in trig to use theta. But anyway, sine and cosine do not have to be changed. But tangent we can change to be sine theta over cosine theta, because that's what it's equal to. And then, just like we did before, after we write in terms of sine and cosine, we simplify. Cosine theta is the same as cosine theta over 1, and the cosines can cancel out. So that leaves you with just sine theta equals sine theta, which is clearly true. So with tip number 1, you will often rewrite in terms of sine and cosine, then rewrite it. We'll do the same thing with this example. The right side, 1 plus cosine x over sine x, is already in terms of sine and cosine, so I don't have to rewrite any of that. But the left side is not, so I will need to rewrite it in terms of sine and cosine. So cosecant x is the same as 1 over sine x. Cotangent x is the same as cosine x over sine x. And then the right side, we'll leave it just like it is. No changes needed on the right side since it's already in terms of sine and cosine. Okay, now the left side we need to simplify. We have two fractions, but they do have the same denominator, so they can be combined into one fraction. So they can be combined into 1 plus cosine x on top, all over sine x on the bottom. And once you combine those, you can see it's a perfect match for what's on the right side. So now we have shown that this original equation is a trig identity, where they are equal to each other. Alright, I know this one looks pretty hectic, but it's not as hard as it may look, so just bear with me. The left side needs no change, because it's already in terms of sine and cosine. The right side will need to change it up. So first I'll rewrite just the exact same thing on the left side. Again, no need for changes, since we're already in terms of sine and cosine. On the other side, we'll rewrite secant as 1 over cosine theta. And I just leave the 7 there. And then 5 cosecant theta is the same as 5 times 1 over sine theta, because cosecant theta is equal to 1 over sine theta. Okay, one thing I can do to rewrite this, make it a little simpler, the 7 and the 5 can just be written on top of the fractions. If you want to think about it like rewriting them as a fraction, 7 over 1 and 5 over 1, you can. But the easier way to work with these is to put the 7 and the 5 on the top of the fractions, because that's the same thing. So I'll have it as 7 over cosine theta plus 5 over sine theta. Now in the previous example, we were able to combine the fractions very easily because they have the same denominator. But this time they don't. One of them has a cosine theta, one of them has a sine theta. So the only way we can combine these two is if they have the same denominator, meaning we need the 7 over cosine theta, the part on the left, to be multiplied by sine theta over sine theta. Because then its denominator will have what the other has. We need them both have the same thing, so they both need sine and cosine. So the fraction on the left, 7 over cosine theta, will multiply by sine theta over sine theta. And then the fraction on the right will multiply by cosine theta over cosine theta. And here I'm just simplifying that fraction on the right. But while I'm writing what's happening on the right-hand side, just let you know, if you go farther in mathematics, like in college, you'll find a lot of proofs. Mathematicians' favorite tricks are multiplying by 1 or adding 0. That may seem weird, but that's exactly what we're doing right here to combine these two fractions. Sine theta over sine theta is equal to 1, so we're not actually changing the fraction. Cosine theta over cosine theta is equal to 1, so we're not actually changing the fraction. So as I simplify that fraction on the right, I'll have 5 cosine theta over sine theta times cosine theta. And if it helps you see, I'm not going to draw this, but these still are the same fractions. Fraction on the left, if you canceled out the sine thetas, you'd end up right back where you started. Fraction on the right, if you canceled out the cosine thetas, you'd end up right back where you started. But here again, we do have two fractions with the same denominator. So we can combine them into one fraction. So 7 sine theta plus 5 cosine theta over sine theta plus cosine theta, which, hey, that's exactly what we started with on the left in the first place. So they are equal. Whew, I know that was a lot. I just have one more example. One reason I knew to only use that first tip for the first examples was none of them had squareds in them anywhere. All of them were just to the first power. But with this last example, you can see, oh wait, we have some squareds. So that should be a big tip-off. We'll need to use the tip number 2 at some point. But I would start with what we've been doing all along. Rewrite everything in terms of sine and cosine to begin with. So for the first fraction, we'll leave sine A alone. We'll rewrite cosecant A as 1 over sine A. Then we'll leave cosine A in the numerator alone, but rewrite secant A as 1 over cosine A. Now, if you know the other trig identities, there's other ways you could approach the right-hand side. But I'm just going to stick with it the way it is. Cosecant, if you remember, is equal to 1 over sine. Now, I want to make sure you understand this notation. With trig, they sometimes write the squared in between the trig function and the variable, in between the cosecant and the a. But another way we could write this is actually with parentheses and write cosecant of a all being squared. So cosecant squared a is the same as cosecant of a squared. Those two mean the exact same thing. So that's why I'm allowed to rewrite cosecant of a as 1 over sine a and cosecant squared a as 1 over sine squared a. And then I'll use the same idea with cotangent squared. Cotangent is cosine over sine, so cotangent squared is equal to cosine squared a over sine squared a. So now we've got a lot of simplifying we need to do. We've got fractions all over the place. On the left side, I'm dividing by a fraction, so I'm just going to treat the top as a fraction, sine a over 1. And to divide by the fraction on the bottom, I just need to multiply by the reciprocal. I'm going to do the same with the fraction on the right as well. So I'm dividing by a fraction for both of those. To do that, I multiply by the reciprocal. And once I write all that out and simplify, you'll see I get sine squared a plus cosine squared a, which should look pretty familiar. That's the Pythagorean trig identity we talked about in tip number 2. On the right side, we see we have two fractions with the same denominator. So I can combine them into one fraction. 1 minus cosine squared a over sine squared a. Now that also should look familiar, because like I told you, that trig identity, sine squared a plus cosine squared a equal to 1, can be rewritten. So I'm going to go back and show you that in just a second. So you can see the forms I'm talking about for that trig identity. So sine squared plus cosine squared equal to 1, we can rewrite it by subtracting the cosine squared over to the right side. So now we can actually substitute either one of these for the other. So I'll just substitute sine squared in for 1 minus cosine squared, because those are equal, so I'm allowed to substitute them. And then I know sine squared plus cosine squared is equal to 1. And obviously anything over itself is equal to 1. So sine squared a over sine squared a is equal to 1. So we did it. We've used both tips now to prove this identity. So stick with those two tips, and I wish you the best of luck. Just stick with it, and you'll get it.